Hey guys, this topics video is a multiplying two binomials to make a quadratic here. Two linear factors. If we multiply them out, we'll get our quadratic in standard form. And so the test taker's job is to actually do that and then write in the box what they get out in standard form. So a cool activity that I actually did this year came from an NCTM lesson. Had to do with actually students visually seeing the product of two lines makes a quadratic, and that's what I'm going to do for this video here. So I'm not going to, but you can make your slope and your y-intercept of this line to be their own sliders, and you could also do it here as well, and it'll create and then we can change around the slope and the y-intercept values of both. But for this video, I'm just going to go ahead and put it in exactly as we see it, and then just analyze this quadratic in standard form. So, or see what kind of quadratic we get, basically. So this could be a point where you're trying to introduce this concept of two linear factors make a quadratic. So the first one is 2x minus 3. So in my GeoGebra, and the input bar, I'm going to type in our equation 2x minus 3. So there's our first line. I always have to make mine a little bold and stand out a little bit. The second line was 5x plus 6. So we have 5x plus 6. Here's our second line. So again, make it stand out a little bit and make it a different color. So may want to zoom out a little. I always like to keep my x, on the x-axis when we look at it, going from 10 to negative 10 is fine. I'd like to change my y scale. Maybe we'll go by 2s. So here's the idea of, our quadratics as a product of two lines. So what I'm going to do is take a look at putting in an x value for this line and the same x value for this line, and then we're going to multiply those two outputs, right? So let's say that we input a 1 into here. So if we crunch 1 through this line, we're actually evaluating this linear function, this 2x minus 3, when x is 1. And I believe 2x minus 3 is the red one, so when x is 1, it looks like we're going to get out a negative 1. Also, when x is 1, in the second line, 5x plus 6, notice we get out an 11. So when we multiply our two outputs at 1, when we insert a 1, and we take that negative 1 times 11, we're actually going to get out a negative 11. So there'd be an input-output pair, a point right here where the little hand is. And that's exactly what we're going to do. So I'm going to show you guys a really cool command that I use all the time that's going to be, that's called the sequence command. And what this allows us to do is allows us to create, based off of a sequence, a bunch of different things here. So this code-wise, I'm going to try to write, and again, I have my mouse going here. So what the code looks like is sequence just so you know what I'm going to be typing in the input bar here. Okay, and we use square brackets, so we're gonna create a sequence. So what it says when we do this is it wants an object. So what we're going to make is a vector. So sorry again, I know that this is not a professional looking writing here. So we're going to create a vector for every time. So this is how the sequence tool or command works. So you tell it what object you want it to make, and then we give it a counter. So if you know anything about code, this is kind of like a for loop. We're going to give it a counter, which you can call any variable your counter. Maybe I'll just say C for counter, comma. Then we have to tell where we want C to start. So starting value. In ours, I'm going to just show the inputs of our functions going from negative 5 to 5. So I'm going to want our C to start at negative 5, and then we say comma to its max value. So every time that the sequence command runs, it's going to create a vector starting when C is negative 5, and then it's going to add 1 to our counter C, which will then be negative 4. Run it through, and then add 1 to -3. And it's going to repeat that all the way to we get to 5 here. So here's what I want to do. I want to create a vector. So we have to know, too, what the vector command looks like. So if you do the vector command in GeoGebra, it tells us, so in vector, if I type vector, we can either just do a point, which will take your initial point at the origin and then go out to the point we put in here. Or you can do a vector with a starting point, comma, end point. And that's how we're going to do this. So here's how this looks in the input bar. We're going to type sequence, put our left square bracket here. Now we want to create a vector. So I'm actually going to type vector, do another square bracket. So within the sequence, we're going to create a vector. So within our vector brackets, we need to put our initial point, which, since our counter, we're going to start at -5 and 5, I'm going to put a point that's going to start at C as its input. And I'm going to make my C start at -5. So right now, when this thing starts, that C value will be -5, comma, 0. So that'll put a point. Our vector will start at -5, 0, when C is -5. So that's our initial point. That's where the vector is going to start from the x-axis. Comma, and now it's going to go to, let's do this for the first function, so for f of x. So I'm going to type in here f of c. So that'll actually evaluate our f function, this 2x minus 3, when x is our c value, so in this case -5. So it'll crunch that through and give us our output. So now we have our vector, so it's starting at the x-intercept. So again, if c starts at -5, basically we're going to have a point start here at -5, 0, and then it's going to end at f of c. Oops, I need to put an x coordinate on that. So after my my comma, I need c, comma, f of c. That makes more sense. So now this point where we end up will be ending on the same x coordinate. That's why they're both c. But this is now going to end up where the vector will actually touch the function at c. Okay. So what we have now, and you can see too, what's nice about the GeoGebra is it tells you when you're outside of some parentheses or brackets. It'll highlight the pair so you know what we're looking at. So I need to go within here. Our vector's done. We got the initial point, comma, terminal point. Now after the vector, I'm going to hit a comma. We have to tell in our sequence command still what our counter is, and that's what this c variable is. And comma, we're going to start at -5, and we're going to go to 5. Okay, so now when I hit enter, look what we get. We get a whole bunch of vectors that started at -5, went up to 5, and when c was, say, -4, now we have the starting point at -4, 0. We evaluated our function at -4, and that's what we get here. So my list, I'm going to make it, just to finish, I'm going to make this red to match my f of x outputs. And that's exactly what these vectors represent, are the outputs when we put in these x values. Okay, I'm going to do the same thing now with g of x. So I can actually double-click my list, and here's my code for that sequence. So I'm actually going to change, I'm going to copy this and cancel, and then I'm just going to paste what I had in my input bar. So we have a lot of the good stuff in here. We're just going to do the same thing for g of x. So everywhere there's an f, which I think is just one place, I'm going to put a g, and now it's going to evaluate our g function. So when I hit enter, there's our green vectors for our g function. Okay. So here's the cool thing. So now we can start looking at the outputs as vectors, and it's neat to see that, you know, the idea is we're going to take the output from the red function from f of x times the output from the g function, the other linear function. When you multiply those two together, those products of each of these outputs, when we multiply them together, is going to create our quadratic that we get. So a couple ways you can go about the quadratic introduction now. You may want to multiply these outputs. Okay, so one way we can do that is we're going to do another sequence. So maybe I'll go Control V again since I have this all pasted. So what I want are a new vector that's going to multiply our outputs here. So we have a sequence. We want to still create a vector. It's still going to start on the x-axis, so this c comma 0 is good. Now here where we want to finish, it's still going to be the same x value, but for my output, we have f of c already in the code, but now I want to take it times g of c. So I'm going to type g of c times f of c in the y output. So this right here is really going to take the output of our terminal point of our new vector. We still want to go from c starting in -5 to 5. So if we hit enter, now we could talk with our students in this list. Let's go ahead and make it a different color. Maybe blue. So this list is actually showing our products of our outputs. So a negative times a negative makes a positive, right? So you can kind of see that we have negatives, negatives. Now here, all of a sudden, we have a negative output, and that's because in our f of x we had a negative output, but our g of x we have a positive output. Okay. Now some other key things to note with this kind of angle at looking at factored form, where a line equals 0. So notice right here, that would be some negative 1 point something. When we put that into our equation, we're going to get out as 0. And notice on this one here, when we put in, it looks like a 1.5, we're going to also get out as 0. And remember, we're multiplying these two outputs. So that's exactly where our quadratic is going to cross the x-axis as well. It's where these two lines cross. And that's really how we solve quadratic equations, right? So now we can just go ahead and put in our factored form. I can actually take f of x times g of x. And if we put that in our input bar and hit enter, we can now see our curve that now touches where our quadratic outputs touch. Kind of see that there. So with all that said, I showed you quite a bit of stuff here, but the idea is our factored forming in algebra of a quadratic is taking a linear function times a linear function. So this is a really cool way to show that when you multiply those outputs at that same x value, then the product of those outputs is what creates this quadratic curve. And what I like about this thing is we can look at when we get a positive output on our quadratic, it's because we're either taking a positive output times a positive output or a negative output times a negative output, which gives us this positive region. And then inside we have this negative region, which is taking a positive times a negative. So anyways, you could have all sorts of fun discussions with that, and it helped my students for sure learn about factored form and how we graph and how we solve quadratics in factored form. So I hope that made sense, guys. Good luck with that.